which depend on the size of component of 2D radiography scans and superimpose them to create 3D radiographic image. In industrial setting, the computed tomography can be achieved in two ways. The first method is the component remains stationary, but the X-ray and the radiation sources and X-ray detectors will rotate. And this method usually used for bigger component, but for the second method, it usually used for small components, which the small component will rotate 360 and the X-ray detector and radiation sources will remain stationary. So the advantages of computed tomography is it provides highly accurate image, is repeatable and reproducible, and minimize human error. And the advantages of computed tomography is it's timely, expensive, and require larger amount of data storage. Okay, so I will pass to Daya. Daya will explain about film development and image quality for industrial radiography.
As explained by Najah just now, there are a lot of types of industrial radiography. But nowadays, mostly the company is still using the conventional radiographic technique. So they are still using the film. So we will look into the film development. So there are 6 steps in developing the exposed film. So we know the film used consists of silver halide crystal. So firstly, the exposed film will be inserted into a developer tank, where this developer tank there is an alkali solution which it is used to reduce the silver halide crystal into silver metallic. So after that, the film will be inserted into a stop bath solution, which is normally it is an acid, a weak acid solution, or it can just be a tap water, and this is used to rinse the chemicals, the developing chemical on the film and stop further developing on the film. After that, the film will be inserted into fixer tank, and this fixer solution will remove all the undeveloped silver halide crystal, and it is used to fix all the developed silver halide crystal, and the fixer also used to harden the film so that it is easier to be handled. The step 4 is final wash. This film is then inserted into a tank, and then it is washed to remove all the fixed chemicals, and this if there is any fixed chemical left on the film, it will affect the quality of the image produced. After that, the film will be inserted into a wetting agent tank, where it promotes even drying, and finally the film is dry and it is ready to be viewed. And as we know, the film can be viewed either by using conventional, or maybe we can use computerized technique to view the film. Okay, I will proceed to the quality of the image, and this quality of the image is depend on 3 factors, which are image density, contrast, and definition. So for the image density, it is defined as the degree of blackness on the radiograph. So basically, in order for the radiograph to be viewed, there must a maximum and minimum density on the film, so that it can be readable and it can give required sensitivity. So the sensitivity is depend on the same 3 factors. image definition, contrast, and density. We can calculate the image of the density of image by using the formula log 10 multiplied by ratio of intensity of incident light and the intensity of transmitted light. So nowadays, if we are using computer technique to view the image, we can directly get the image density by using an application called ImageJ. The second factor is contrast. Contrast is the degree of difference between density field on a radiograph. Radiographic contrast is depend on two factors, which are film contrast and subject contrast. So film contrast is called difference in film density due to type of film used, how it's been exposed, and how it been developed. So film contrast, for example, if we are using large grain film contrast, which means like the silver halide crystal is large, so the time of the film process will be reduced, and this contribute into high density difference in the film, so the contrast will be higher. Next is subject contrast. So that the subject contrast is depend on thickness and density of the subject itself, and the radiation quality. The radiation quality is we can look at the energy of the X-ray is being used. I mean, like the high energy means we use the low wavelength of X-ray. So so the higher cavity we use, the smaller wavelength is used to, and it will reduce the subject contrast. Okay, we can proceed to the image. This one is referred to the subject contrast also. This one is in terms of contrast. This one is higher contrast compared to this one. This is due to the length of the wavelength used. As I explained just now, this one is just a comparison between the high contrast and low contrast. So in industrial radiography, we want the image to be in high contrast so that we can easily look at the defect in the subject. So we can look at the third and last factor of the image quality, which are definition. Definition is the degree of sharpness at the boundaries of density field. So we will look into the last factor of image quality, which is definition. So definition is the degree of sharpness at the boundaries of density field, and usually in the image there is like an amount of inherent unsharpness form as we use a high energy of X-ray or gamma source. So we can see here, this one is a good definition of image produced, and this one is poor definition of image produced. And we can see this is amount, like I said before, the unsharpness form due to high energy use. In industrial radiography, it can be happen the low definition, but it is limited into like a certain amount. So the unsharpness can be happen, but it is limited into 1/100 of the thickness of subject being observed, and this 1/100 of the thickness can be larger up to 1 micrometer, and this one we call it as the length of penumbra. So as we can see here, this one is the penumbra, and it can be calculated by using the formula of unsharpness. We can calculate the penumbra or unsharpness by using the formula UJ. Unsharpness is equal to the focus spot size multiplied by the ratio of B/A, where B is the distance between the surface subject to the film or detector, and A is the distance between the source to the subject surface. So we can still minimize the definition by reducing the focus point, and as we can see here, the smaller the focus point, the smaller the penumbra form. The eye sharpness can be reduced by using a small focus point of the sources used, and we can use we can increase the length between the source and the subject and reduce the length of the source and the film. So we can see here, there's like a minimal penumbra form. So this is what we want in industrial radiography. So that is all from me. I will proceed to my friend Selwan to explain about the advantages of industrial radiography.
So the first advantage of the radiographic testing that it can be detect both internal and surface cracks, and also can be detect the variation in composition, and it has a very few material limitation, and it doesn't require any direct access to the surface or a preparation for this surface. It can be used for the hiding areas. And also permanent testing record is obtained. The final point of this advantage is radiographic testing can be carried from place to place, especially for the gamma ray source.
So the main important thing of the disadvantages is the hazard of radiation. So while dealing with radiation, the workers were exposed to radiation dose. This dose can affect on their biological tissue, like their health. We have effects for long term or short term. Like for the long term, maybe they will have cancer in the future. The second disadvantage is it requires a very high skill and also experience for the worker to deal with this method or applying this test. It also required a very high expensive requirement to, in order to obtain this test. Going to the procedure is very slow, and in the image it cannot detect the depth of the discontinuity. It also needs a high directional in order to obtain the crack or something. For example, if the X-ray is not parallel to the crack will not be seen. Going back to the hazard, if you want to reduce the disadvantages in order for the method to be widely used, the hazard can be reduced by following the safety rules, like wearing the proper clothing, like before dealing with the radiation. And also, while we are dealing with radiation, we need to have shielding to prevent the radiation or to reduce the radiation. Also, we need to be as far as we can from the source, like the distance. And the last thing is to lower the exposure to radiation. Like we try to make as soon as possible, to reduce the exposure time. Following these rules can reduce the radiation hazard. And that's all from us. Thank you for watching.
So that's all from us. Thank you.
Thank you.
Thank you.